Hello my friends, this is 14th issue of the Weekly Links. I really want to know how do you find my show, and if you like it, please give me a thumbs up and write a comment. What's the agenda for today? Virtual threads in Jakarta EE, a new job about loading of Java agents, Spring Boot actuator endpoints, and a couple of articles about Java concurrency. My name is Alexander Barmin and this is my channel. Brew your morning coffee, set up a timer, subscribe to my channel, and let's get started. Let's start with Java for enterprises. Upcoming Java 21 brings a bunch of new features and capabilities, and one of the most expected features are related to concurrency. It is virtual threads and structured concurrency. Java EE is a quite strict environment that offers dozens of APIs that allow to control almost every aspect of the application, so that developers can focus on the business code only. On the one hand, it has benefits. It is not necessary to think about underlying layers like persistence, storage, concurrency, data conversion, and so on. On the other hand, it creates some lack in adoption of new features because, apart from Java releases, it is also necessary to expect new Jakarta EE releases that will bring support of new Java features. Get back to Jakarta EE. Jakarta EE 11 is the upcoming new release of the Jakarta EE platform. Targeted release date is Q1 2024. In Jakarta EE, applications run inside servers, so that servers manage many aspects of the application. For example, creation of thread pools and management of threads. This means that developers do not create threads manually, they borrow threads from the platform. Jakarta EE has an abstraction called a Managed Executor Service that is responsible for doing the work in a sync way. Starting Jakarta EE, it will be possible to request a new application server to use virtual threads by customizing the executor service. So that it is just by putting a new management executor definition annotation you may improve performance of your application. Structured concurrency with task scopes also will be available in Jakarta EE 11. By the way, do you use or even try to use Jakarta EE? I did, and actually I can say it was a bad experience. So what was your experience here? Before talking about the next article, it is necessary to talk a little about Java agents. Java Agent is a specially crafted jar file that uses instrumentation API, which allows to modify bytecode of classes already loaded to Java virtual machine. Roughly speaking, it allows to modify the code in runtime without actually knowing the code. There are not so many scenarios when it might be needed, but still they exist. For example, tracing is one of them. You don't need to pollute your existing code with annotations for establishing tracing of requests, integrations with various monitoring systems like AWS X-Ray, Dynatrace, Datadog. Instead, these systems can be added to existing applications like plugins. There are two main ways to load the Java agent: static and dynamic. In case of static load, the agent is defined using Java agent command option in the command line. In case of dynamic load, the agent is attached to the running application using Java Attach API. So in case of dynamic loading, some agents may be attached to the JVM unintentionally, and you may not even know about it. Obviously, JVM signals about it by showing warnings in logs, but it might not be noticeable. JEP 451 is the first step to disallow dynamic loading of agents into the running JVM. The main goal is to improve integrity of the JVM but still provide a decent level of serviceability. This is the first JEP in the series of changes related to Java agents. Dynamic loading of Java agents can be switched off in one go because there are many tools that utilize these capabilities, starting from logging and monitoring tools up to more complicated things like profilers. By the way, have you ever written Java agents? Put your answers in comments. Let's move forward and talk about Spring Boot. Spring Boot Actuator is a great extension that allows to get information about running Spring Boot application. For example, regarding its health, available and used memory, it also allows to change login level on the fly and perform many other service operations. And also it provides a great extensibility and allows to create own custom HTTP endpoints. Obviously, yes, you can create a REST controller and Spring Boot application and it will provide any data you want, but in case if you create an actuator endpoint, you can manage it more flexibly, enabling and disabling on property, protect with actuator security, and so on. When you create a new Spring Boot actuator endpoint, you may define multiple operations in it, but in common there are 3 common types of operations supported: read, write, and delete. All correspond to 3 REST methods: get, post, and delete. The idea is that you create a new class annotated with @endpoint annotation and define methods. Annotate these methods with read operation, write operation, and delete operation annotations. Methods will be automatically mapped to REST calls, and your endpoint will become available under the actuator endpoint. And 2 last articles are about Java concurrency. Java has a few building blocks for concurrency, and synchronized keyword is one of them. These keywords allows us to create synchronized methods and synchronized blocks. The main advantage of using it is that it is simple. You just define the block and it works. In case if you have only one method where you should manage concurrency, it is easy. But in case if you have more complicated way of dealing with shared resources, it is not so easy. To have more granular locking, you may use the lock interface. The interface itself defines a few methods like lock and unlock that allows to acquire the lock and release it. It also offers a couple of try lock methods that allow to acquire the lock only if it is free at the moment of invocation or free within the given waiting time. Lock is an interface and it has 2 main implementations: reentrant lock and read-write lock. Reentrant lock allows to acquire the lock multiple times by the same thread. Actually, enter the locked block if the thread already owns a lock. Reentrant read-write lock is a next step, and it allows to separate read and write operations. The idea is that read operations can be executed in parallel, but write operations require exclusive access. It is also possible to downgrade the lock from write to read if needed. The second article is about conditions created by reentrant locks. Conditions allow threads to wait for a specific signal before starting the execution. The closest analog might be the wait method on the monitor object. As ordinary, more details are in articles. That's it for today. Hope you enjoyed the video. If you have ideas for future issues or have articles you want me to read, do not hesitate to add them in comments. If so, please give me a like, subscribe to my channel, and see you next week. Bye!